In this video lesson, we take a look at prime factorization, which is a skill introduced in section 3.1 of your textbook. Prime factorization is important for us as Math 10 students because it's one of our main strategies for answering questions in Chapter 3. In order to be able to do our quizzes and tests in the time allowed, we need to make sure that we can quickly and correctly find prime factorizations, especially because this skill is used to help answer other kinds of questions. As a warning to all Math 10 students, you are expected to be able to do these factorizations, and we need to do them quite quickly at times, which means that you're expected to know your multiplication facts or your times tables for 0 to 12. For some students who are very dependent on their calculator, this might mean that you need to do some extra practice this week at home. With that said, we're going to remind ourselves that factors are numbers which multiply together to give us the value we started with. We know that 2 multiplied by 5 equals 10, so we can say that 2 and 5 are factors of 10. We would consider 10 to be the number we started with, and factors are numbers that multiply together to give us that 10. If we consider all the factors of 24, 24 is 1 multiplied by 24, or 2 multiplied by 12, or 3 multiplied by 8, or 4 multiplied by 6, and 24 doesn't have a factor of 5. This is our complete list. The other vocabulary term we need this lesson is a prime number. A prime number has only 2 factors, 1 and itself. So for example, 3 is a prime number because its only factors are 1 and 3. The number 1 is not a prime number because it only has 1 factor. And the definition of a prime number is that it has to have 2 factors. So unfortunately, 1 doesn't make the list. If we're going to consider the first 12 prime numbers then, it's useful to just start counting. 1 is not a prime number, but 2 is. 2 is one group of 2, and 3 is one group of 3. 4 is not because it's 2 multiplied by 2. 5 is. 6 is not. 7 is. 8 isn't. 9 isn't either. Even though it's an odd number, 9 is 3 groups of 3. 10 is not. 11 is. 12 isn't. 13 is. 14, 15, and 16 are not. And we keep going. The first 12 prime numbers take us all the way up to 37. A composite number is any number which has more than 2 factors. So if we're going to think about our first 12 composite numbers, we can find them much faster. 1 was the special case, 2 and 3 are prime, 4 is composite, 6 is composite, 8, 9, and 10 are all composite. Notice how we're essentially circling all the numbers we ignored when we were looking for primes. Let's keep going until we find the first 12. And here they are. We've got a lot more composite numbers than we have prime numbers. The last piece of information that we need before we can talk about prime factorization is a quick review of exponential notation. Remember that exponents are a way to show repeated multiplication. So 5 multiplied by 5 multiplied by 5 can be written as 5 cubed, or 5 to the power of 3. And 2 multiplied by 2, multiplied by 2, by 2, by 2, by 2, that's 6 2's all chained together, so 2 to the power of 6. In this last line, we have 3 multiplied by 3, or 3 squared, multiplied by a single 5, multiplied by 1, 2, 3, 4 7's, and so 7 to the power of 4. We're going to use exponential notation to help us with our prime factorizations. So what is prime factorization? This is the process of breaking a number down into its prime factors. and we use exponential notation to show repeated multiplying. The other piece is that you will notice in your textbook and in our answer keys on the classroom that we're always going to start with the smallest factor and work to our largest. So let's consider a prime factorization of 120. I notice that 120 is divisible by 10 because it's got a 0 at the end. So I might start out thinking of this as 10 multiplied by 12. Neither of those is a prime number, so we're going to break them each down a little bit more. 10 is 2 multiplied by 5, and 12 is 2 multiplied by 6. Notice that we're keeping track of the numbers which multiplied together to give us 10, and the numbers which had multiplied together to give us 12. 2 and 5 were prime numbers. They aren't going to change. For the factors of 12, 2 is a prime number, but 6 is composite. It can be rewritten as 2 multiplied by 3. Now we have our prime factors, or our prime factorization of 120. Altogether we have 3 2's multiplied together, and 1 3, and 1 5. If you like, you can include the exponent of 1 with your 3 and 5 to remind you how many were multiplied together. If we consider the prime factorization of 104, 104, the last two digits, 0, 4, are a multiple of 4. So we can think of 104 as 4 being multiplied by 21. That 4 can be broken down into 2 multiplied by 2, and 21 can be broken down into 3 multiplied by 7. This setup is called a factor tree. Some students prefer to show their factorization in this form. Other students prefer to show their work in a more condensed form, simply breaking down into the factors. Whether you like the factor tree or the more condensed form doesn't make a difference. The most important piece is that you can begin to successfully say that the prime factorization of 104 is 2 squared multiplied by 3, and give it an exponent of 1 if you like, multiplied by 7, and again the exponent of 1 if you like. This is an important enough skill we should look at 2 more examples. For the prime factorization of 360. 360 is 36 multiplied by 10. Neither of those is a prime number, so we'll break them down. And now we found some prime numbers, but 6 still needs to be broken down further. If you're a student who likes the factorization tree strategy, don't forget to carry down any prime factors that you find partway through your work. We don't want to forget about them. Altogether in our factorization we have 1, 2, 3 2's being multiplied together, or 2 cubed. We have 2 sets of 3, or 3 squared, and we have a single 5, plain old 5, or if you like 5 to the power of 1. And here's our prime factorization of 360. As our last example, we're going to look at the prime factorization of 2880. To get started, we can see that this is a multiple of 10. In other words, 10 is a factor. And as a hint, 288 can be rewritten as 2 groups of 144. Hit pause now and see if you can finish this prime factorization. Your middle steps might look a little bit different from mine, but this is one of the nice things about prime factors. We should all get to the same place in the end. We notice that our factors of 10 are fairly simple and don't change all the way through. The factorization of 288 becomes a little bit more complex. That original factor of 2 carries down. I chose to factor 144 as 12 multiplied by 12, and then I used some purple color to track the factors of 12. Regardless of your middle steps for your factorization, and whether or not you chose to use color, you should still have ended up with this final version of our prime factorization. If you didn't, try again and see if you can figure out where you gained or lost factors. As a reminder to grade 10s, this is a very, very important skill. It's going to be very necessary to make sure that you're completing the notes and the viewing guide, and that you're doing all of the related practice. If you have questions, don't forget to ask in class.